Okay, we're on angles and degree measure, or degrees and angle measure.
You guys are unbelievable.
Chuckle, funny. Yes, I said measure. Maybe I'll just laugh at your test score next.
Oh.
I win.
He does it anyway.
Okay. No, I don't actually, because it's, yeah. Okay, the vertex. What about that? You guys know what that is, right?
Yeah.
This is also called the initial side. That's where we start. And this is called the terminal side. You're going to start learning a lot of Greek letters. Okay. So yes, we were evil when we inserted the alphabet in mathematics, X and Y and Z. Now we're going to insert the Greek alphabet into mathematics. Okay, pi is one of those you've seen. But this, we're going to start using them pretty heavily. So that angle we're going to say is alpha. Okay, it's a little fishy, basically. Yeah, it does that too. Yeah, yeah, like this.
Don't finish an 8. Or make an 8.
Just, yeah, make the infinity side, just don't finish it.
A big part of trig is putting these on the coordinate plane. Have you guys done that at all? Put angles on the coordinate plane?
Yeah.
I don't remember if we did or not. Okay, this is called standard position. You put the initial side on the x-axis. So there's your initial side. What's a possible measure for that angle? And then the terminal side is in what quadrant?
The first one.
Quadrant 2.
Oh, wait,
Remember? 1, 2, 3, 4. So angles are going to follow that progression as well. Okay.
So wait, is the initial side, is that on one or is it just?
It's on the x-axis. Positive angles go counterclockwise, just like the quadrants. So. What about negative? Makes sense. What's the other way, Mikey? Yeah.
No. Wait.
Okay, so a negative angle would be same start spot. We're just going clockwise now. Okay. All right, so that's all definitions, really. It's just stuff you have to remember. Okay. Yes. How many degrees are there in a rotation? You all know that, right? Yeah, I'm hearing whispers. Okay, one rotation is 360 degrees. Can I trust that you know how to calculate the degrees measure for 5 rotations?
Yeah, it's just five rotations.
Okay, yeah.
Okay, I actually knew how to do it, but you just did your head, so.
Who said, who knew what? Come, what?
Come on.
Come again. What?
I'm
I'm not confusing me. I'm confusing her. What? I'm just kidding. Okay. All right. So you're probably okay with that. Okay, coterminal angles. You know what the terminal side is? Okay, coterminal angles share a common terminal side. Let's start with $50. It was colder than that, my friend. It was definitely in the 20s.
It felt great this morning.
Beautiful weather for wearing a t-shirt and shorts.
Mm-hmm.
Okay, a coterminal angle could be 410 degrees.
I thought it would be.
They share a terminal side, right?
Oh,
They terminate in the same spot.
a little bit.
So this is
Easiest day.
360 plus 50, right?
Yeah. Is that how you get 4?
Yep,
Why would you add 360 to it?
because it's one full rotation. 360 plus another 50, so they end in the same spot. Okay, I didn't know that would cause an eruption. I feel like I'm in Hawaii right now. There's a volcano erupting about to run over a town. What's that angle measure?
Would that be 5? No, that's gonna be
Backwards.
3. It's negative.
Mine is negative.
So
Yeah. 360 minus 50. Okay. Is there a general formula you can think of to account for every single coterminal angle? You're thinking on the right track.
That's minus A.
Okay, it's the angle alpha plus what? 360 times k. K is an integer. So I can plug any integer into that formula. Okay, in our case, for this example, I just used 1, right? If I plug 1 in, I get 50 plus 360 and 50, and then negative 1 would be 50 minus 360. I don't know. So what was alpha in this problem? 50. And what was k here? 1. So 50 plus 360 times 1 is 410.
how do you get 2? Where do you get 1 from?
Pick it.
Oh. So units for K is how many rotations?
Okay. Yeah, k is the number of rotations, basically. Sometimes you get to pick it. Well, you can pick 2. What's 50 plus 360 times 2? So 770 is another coterminal angle. How many coterminal angles are there? Yeah, an infinite amount. Okay. So that's coterminal angles. So I don't know why. I'm showing, okay. 50 degrees, right? Add a rotation to it. It ends up in this spot. That's a coterminal angle. 410 degrees. 50 plus 360. They are two different angles. 50 is an angle and 410 is a different angle. But they're called coterminal because they end in the same spot. They look the same. Yes. Let's see if you get this. Name an angle coterminal to 135. That's one. I don't care. I said and. So Dylan says the formula, right? Alpha is 135, and for Dylan, K was 1. Okay, give me another one. Okay. What'd you choose for your K value? 2? Okay. You get it? A little bit? Okay, you're just going around a number of times. Okay, the other way is to name an angle that 935 degrees is coterminal 2. So you got to find, you're finding, and we'll add a little caveat there, in quadrant 1. Or how many rotations is that? 67, 20. Quadrant 3.
Wait, coterminal to what?
Name an angle that 935 is coterminal to in quadrant 3. Yeah, that's very, very poorly worded sentence, actually. You'd think my grandma was an English teacher, so yeah, she was. That's why I speak English pretty well. I was as good in English as I was in math. Let's put it that way.
Why'd you choose that?
Because I like it better. My apologies. Okay. So we know that this is true. Right? We have two variables. Can you solve this yet? Okay. We have to figure out what K is. So what's 935 divided by 360? 2 point something? Can somebody give us the exact 2 point something?
2.5.
Okay, we need to use the 2 as K. 2 revolutions. If we use 2, for that K, what's left over the 0.59 is our angle. It'll give us alpha if we take that 0.59 off. Nope.
Okay,
No, now solve this equation for alpha. Yeah, subtract this over here, right? What's alpha? Brandon, you said it. What's 0.59 times 360?
Was I right?
I think you're right. Check it.
Oh, yeah, because that's like, yeah.
Oh, well, we didn't do 0.597-ish. But you can see they match. There are two different ways to do it. Right? You can solve the equation or you can use the decimal, but be careful on the decimal that you don't truncate it too much because it can cause issues. The exact, again, we'll reiterate this all year, the exact method is the algebraic method. Okay. You okay with that?
Why?
What else? Oh, yes, reference angles. This is probably the most important part of today. Reference angles. No, we will not be referencing major pain for these. I know. Look like we got a sickly boy on our hand. When we use sine, cosine, and tangent here in the next few days, we don't like to deal with when it's in degree measure. Okay, we're going to show you something called radians to deal with this, but when we deal with degree measure, sine, cosine, and tangent do it between 0 and 90. Right, so 125 degrees with sine, cosine, and tangent is a no-no. So we have to have reference angles. Okay. I haven't showed you what it is yet. There's nothing to be lost about.
Yeah, but I don't know what you just said. No.
It's just informational for the future. We can't use angles above 90 degrees. The question is, how do we make that one? How do we do that with sine, cosine, and tangent? We reference it with the x-axis. So this is our reference angle here. Yep. What's that? 55 degrees.
Oh.
You have to finish it to 180. Okay. So we're referencing that with the x-axis. We want to be less than 90 degrees. Okay. Let's try another one. Let's make that just a touch smaller. Okay, it's ugly all the way around. What about this angle here at 300 degrees? What's the reference angle? Yep. You reference it with the closest x-axis. Right there. Okay. That right there is probably the most important thing you're going to see today. So know it. Are you good?
Know it.
Wait. Yeah.
Excuse me.
Live it.
All right. Yeah, you have about 20, 22 minutes to hopefully finish this. But for those of you that I'm going to reiterate this time and time again, those review problems. A lot of you are earning 2s on your test, 2 5s. You're not happy with those, right? A lot of you. Yeah. The spiraling is the way to get rid of that score. So when I score your tests that we just took Friday, chapter 1 will now have the original test, 1 spiral plus the test spiral that we just did. Okay, I'm only going to keep 2 of those. If your low score was the original test and the 2 new scores are better, I'm dropping that big chunk of ugliness. So pay attention to those reviews because I pulled the test problems straight from them. They're not the exact problems, but they're the same concepts. Okay. Eventually you'll spiral that ugly score out. Hopefully you're showing that you're getting better. Okay.